So Paul over at Learn Electronics, he did a little video on Arduino-based ohm meter, and at the end of it, he was asking how he could improve it, and figured I'd take up the challenge. And so I've been working on it for a couple hours. I came back to his site, and it looks like somebody down at the bottom pretty much doing left a comment about doing it the same way I am. But I'll do this video so that you can see what I was up to. Basically, you put your each of your resistors on a different GPIO pin, and if you make it an output and put it to high and leave all the other four as inputs, that the other four will be floating and won't influence your readings at all. I did a little test on it where had two resistors, taken one out and left the other one in, but so it didn't change the readings at all. So I did a little test on, have a couple codes here. I'll show you. So this test just basically returns the analog 0 output for each one here. So basically we're just writing one of the outputs high as an output, and digital writing at high, and pin moding the other four as inputs. And we do that, just go down the list here. If I was doing this for real, I'd probably put this in some type of loop or something, but this is better to explain it, how we're doing it by doing each one. So basically we're setting one of them as an output, and writing it high, and the rest of them are inputs. They just don't affect it at all. So I got an Arduino hooked up. Let's see if it's going to work. I got it wired up the way that sketch was showing. So basically, I think I got a 300 ohm resistor on there right now. So this is taking the 5 readings using the different resistors, going all the way from a 100 ohm resistor all the way up to a mega ohm resistor. And you can see the ADC numbers they're just repeating the 5 numbers over again. So it looks like, so we don't just showing that it's working, and we're getting different ADC numbers with each one of the resistors hooked up. So anyhow. Go down and pull up the next one that I did. So this one basically the same thing, except when I read the ADC, I send it to a function, this find R function. So I actually found this function up here. I didn't really understand the one that you showed us, the link that you showed us, to how he had figured his out and everything. So I actually went online, and this is actually the solving for unknown resistance. This was the best site I could find for that. I'll put a link to that at the end of the video. But basically, we don't even have to worry about voltage. What we're looking for is a ratio between the output and the input. So we don't even have to convert it back to 5 volts or anything, because we got 1024 total, 1023 total, and our output's going to be somewhere less than that. So that's our ratio. So that also is what our F is. So and we just put it in this one down here. We know our reference resistor, and we just put it in the equation here and do the math, and we get it taken care of. So basically we're doing the same thing. The function actually brings in this find R as a function. It sends in the count that we just took, and then plus each one. This is the 100 ohm resistor. This is the 1K resistor, 10K resistor, 100K resistor, and 1 meg ohm resistor. So we're sending the analog read, and we're sending the reference resistor value to the function up here, so we know what we're doing with it. And basically you're just taking your analog read, which is going to be 0 to 1023, and we're doing a division on that. So if we're getting that, so it has to be a float. So that's our F value that we want. And then we just plug it into the equation down there. It was F over 1 minus F. And then we're multiplying that by our resistor value. And we don't care about it being a float, so I turned it back into a long just so we get an integer value. And just basically printing that. Like I said, we're still printing the ADC values as well. So I'll try to upload this one, see if that works. Yep. Looks like I messed up here. Forgot to comment that. Yeah, I'm going to put that in. All right, let's go look what we got now. And so now we're doing the math, and we're showing the readings on this for each one of these. So basically what I've been noticing is that as the ADC is above 700 or higher, it's off. So like I said, there's a 300 ohm resistor in here now. So we when the ADC is above 500, which is the halfway point, I think probably go up to 600 on that. But we can try a couple different resistors in here. I'll change the resistors out as we go. So let me get my ducks in a row here. All right, so I think this is going to be a 68K resistor. So you can see on there, as it got below this 800, it was still off, but around when the first one below 600, I think is the best deal. And it doesn't hold all the way up. I think that's got to do with the resistance on our board. Let's see what we got here. Got my glasses here out. Let me see what we got. It's like a 1K resistor. Let's see what that does. All right, so we got a 1K resistor. And like you say, the nearest one we got is right around that 500. Right in the middle is the sweet spot when the resistors are closest. But that's what we got there. Might as well try them all. So this 470 was the worst one. It's between 100K and 400 and the 1 meg ohm. And it really didn't do very well because This is 470K. And we're really not getting those kind of numbers down at all on that. So that didn't work. But like I say, the meg ohm resistor, we got a meg ohm as a reference, so it kind of comes out real close. So like I say, if you can get closer to the ones you want, right around 500, you got the, well, maybe it's not a meg ohm. I thought it was. Not sure, but yeah, maybe it falls apart up at the higher end. But anyhow, yeah, it just seems to fall apart up there at the high end. So not sure what we can do about that. I don't have anything plugged in now, so that's what's going on with that. Anyhow, Paul, that's what we got going on so far. Let's go ahead and bring up a final sketch. So got this final sketch. It's basically the same way, but it picks the nearest one. It only prints out the one that's when it falls below the 600, the first one that falls below the 600, it prints it out. And then the put a flag up there. So once it finds one, it won't bother getting any of the other ones. We'll see how that works out. Guess I better put a resistor in. All right, let's run our serial monitor. Okay, that's our 300 ohm resistor. So it's coming out pretty good. All right, I'll put our 1K in. One K is working out really well. Like I said, it is our 68K. It works up to that, all right. And then, like I say, once we go to 470. It's thinking it's a 1 meg ohm as close as it can get, so that's not as good. But then when we put the 1 meg ohm in, it really messed up. I don't know whether it's just big numbers or what. Thought I was having better results with the 1 meg ohm before. But now it's actually saying it's 100K. Actually, I'm gonna get my meter out and just test this because it may be, maybe I got the meter, I got my resistor swapped up here. Thought that was a 1 meg ohm. I'm gonna pull it out and check it. Actually, that was a 100K one, so that's why it's working. I have it labeled as 1 meg. So I don't think I must not have a 1 meg, but well, it works up to 100K, all right. But then the 470, it kind of doesn't work out. Anyhow, I'm gonna leave you some graphics. I'll leave the graphics I did in Tinkercad of the circuit diagram, and I'll leave links to my code, and you can download the INO files And also, I'll give you a link to that voltage divider site that I found as well. So, all right, well, thanks for watching. Hope it helps you a little bit.